Evenings are the most busiest busiest time of the week, right? So you have other classes, you have to unwind for the week. Saturday is a very tough day, but then despite that, you guys are here. You've joined our session, and I'm very proud that you guys are here. And what's going on, Sadinsa? My God, I thought you would not join, Sadinsa. Glad you're here. So, how has life been, Sadinsa? How has your the hum parcel been, Nangi?
Pretty good, sir.
Good to know. Good to know. So glad that you're also here. So we got a valuable session ready for the students today. So you know that these days we are focusing primarily, okay, principally we are focusing on the exam. So geometry is a super valuable part because you can find variations of geometry in our syllabus. You can find different kinds of geometry in past papers. So we are going to be doing past paper questions today, but we are not going to talk about everything in geometry. So if you think about it, okay, if you take geometry, a lot of students don't know how geometry is cut because geometry is a very heavy section in our syllabus, Sadinsa. There are different kinds of geometry parts, but today we're going to focus exclusively on circle geometry. Proof geometry is what we are going to focus on. I'll briefly explain what geometry is, okay? Now, when we talk about geometry, a lot of students are confused. Students, they confuse calculation geometry. All right. So if you take geometry, hope you guys can see my screen. Let me quickly share my screen. So our students are a bit confused because under geometry, and if you guys are not in the Infinity Maths group, make sure you guys join because in the Infinity Maths group, we've got that is where we put all of our notes and our links. So if you guys are not a part of the Infinity Maths group, make sure that you guys do join. Sadinsa, Infinity begins from here, right? Infinity begins. That's our tagline, Sadinsa. Infinity begins from here. All right. Lasanavela. What was the lesson that you taught today in your Dham parcel? So my students don't know this, but Sadinsa is also a teacher. She teaches Buddhism. So she's here to teach me Buddhism after the class. But I'm going to teach you guys geometry. So what did you teach today in your Buddhism class, your Sunday school, your theology school, Sadinsa?
It's about the personal attendant of the Buddha.
My God, okay, that's so interesting. All right, please tell me all about it after the class, okay? Give me a private session about the personal attendance of Lord Buddha. Oh my God, okay. So geometry is broken into two parts. We have calculation and then we have proof. So calculation geometry, I think everybody, it's the most famous kind of geometry because you calculate the magnitude of the angles, you calculate volume, you calculate area, right? So no calculations today. This is not real geometry. When we talk about geometry, we want proof geometry. When we talk about geometry, we're actually prioritizing proof geometry. So, coming back to the point, what is proof geometry? It's actually in the name. And I am, I think, the only teacher who will thoroughly break your syllabus down like this. Now, for example, under calculation geometry, we have area, volume. All right. So this is not real geometry, okay? Magnitude, length, magnitude. What is magnitude, by the way, Sadinsa? In Sinhalese, what would you call magnitude? Magnets. Like how big it is, right? Sadhin sir, don't you agree? That is magnitude, right? It's how big it is, how big an angle is, right? What is your what is the magnitude of this angle, right? So magnitude in Sinhalese we call it vishalatva. So magnitude, length. So this is calculation geometry, area, volume, magnitude, length, trigonometry. Trigonometry is not proof geometry. Trigonometry is not really geometry. So a lot of students, they study trigonometry, think that they are learning geometry. No, trigonometry is not really geometry. It is a calculation theory. We use trigonometry to perform certain calculations. So we are not going to be talking about trigonometry today. Pythagorean theorem, right, Sadinsa? Pythagorean theorem. Pythagorean theorem. All right? So these are calculation geometry. We are not going to be talking about them. We are going to be focusing on proof geometry. Sadinsa, do you remember proof geometry? When we learn about proof geometry, we basically segment proof geometry into two shapes. What are those two shapes, Sadinsa, that proof geometry is segmented into?
Circles and triangles.
Absolutely, circles and triangles. You are right. Well done. Circles and so remember proof geo. Everybody listen very carefully. Proof geometry is segmented into two shapes: circles and triangles. But remember, trigonometry is a theory that is applicable for right angle triangles. The Pythagorean theorem is also a theory that is applicable for right angle triangles, but they are not proof geometry. Those are calculation geometry, by the way. They fall under calculation geometry. So under proof geometry, like Sadinsa says, there are circles and triangles. So we have theory under circles, okay? We have the circle. All right, we have the circle. So under the circle, we have tangents. If you don't know what these are, don't worry. I'm just giving you a rough explanation of what geometry is. All right? I'm telling you what actual geometry is, because the reason why geometry is so difficult is because the student tries to put all of these into their head at once. Area, volume, magnitude, length, trigonometry, Pythagorean theorem. These are not real geometry. So today we are focusing on proof geometry. So the first shape is the circle. So under the circle, there are tangents, there are chords. Tangents, Sadinsa, do you remember the tangent touches this? If this is the circle, okay? If this is the circle, the tangent touches the circle from the inside or outside, Sadinsa? Tangent. What do you think, Nangi? Do you remember? Exactly, Amna. Genius, you are, right? Amna says, outside. Yes, you're right. Zayda, absolutely. Outside, right? The tangent touches the circle from the outside. How many places does the tangent touch, Sadinsa? The circle? How many places does the tangent touch from outside? Only. What do you think the answer is? Absolutely, Zaida. Sadinsa, go ahead. Only one, exactly. I saw it. I saw your echo. One place, right? The tangent touches the circle from the outside in one place. But then, so this is a tangent, okay? Tangent. If there is a line that touches the circle from the inside. So there are two methods of touching, right, Sadinsa? You can touch from the outside, Or you can touch from, I'm talking about circles, okay? This is geometry. Like Sadinsa says, we are learning about circles and triangles. So a circle, you can touch from outside and inside. If you're touching the circle from inside, it's called a chord. And you guys can see that the circle is touched in two places. If you're touching the circle from the inside, you must like this. You must touch two places. All right? Javed is teaching you very valuable mathematical theory. All right? This is important for your life as well. This mathematics theory is important, right, Sadinsa? Important for your life. Tangent touches the circle from the outside, one place. Also remember, the tangent is always perpendicular to the center. The tangent must always be perpendicular to the center. But we'll worry about that later. There are two pieces, two ways that you can touch a circle, Javed sir is teaching you. Right, Sadin sir? From the outside, you can touch it. It's called the tangent. If you touch from the inside in two places, it's called the chord, right? It's called the chord. That's the circle. That's the circle, okay? So we're looking at proof geometry. There is another part called constructions. That is also not proof geometry, okay? There's another part called constructions. That also doesn't belong to proof geometry. But right now, we're looking at proof geometry. So there are two shapes. Number one, we have the circle. And then we have the triangle. So when learning about the circle, you have to know what chords and tangents are. There are more parts, by the way. Sectors. We have arcs. We have semicircle, but don't worry about them, okay? Center, circumference. Don't worry about those words. They are extra. What you need to understand is a tangent and a chord. There are two ways that you can touch a circle, right? So in Sinhalese, I would say there are two ways that you can do athavara for a circle. One is the tangent, touch the circle from the outside. Athavara means touching, right? Sadinsa athavara means, right? Atha means hand, right? Vara means come. So touching from the hand, right? That is what athavara means, right? Of course. Tell our English medium students. There are two ways that you can do athavara for a circle. You can touch it from the outside. If you touch the circle from the outside, it's called a tangent. You can touch the circle from the inside, but then you must touch two places, okay? If you're touching from the inside, you must touch two places. And that is called the chord. That's the circle. Now let's talk about the triangle. When learning about the laws of the triangle, you need the midpoint theorem. You need the midpoint theorem. You need the congruence. Congruence of triangles. You have to. Is that it? Midpoint theorem, congruence of triangles. You have to know. You have to know similar triangles. Similar triangles. Similar triangles. Similar or proportionate. Similar or proportionate. Similar triangles. That's it. That's it. Don't worry, we'll talk about these in the future, okay? Midpoint theorem, congruence of triangles, similar triangles. You have to also know that a parallelogram. You must also know that a parallelogram is made of how many congruent triangles, Sadinsa? If I take this parallelogram and dekata bedua nang, right? How many congruent triangles are there, Sadin Sanangi? Looks like the chat is very busy today. 2 exactly. Well done, Sadinsa. Well done, Amna. You're right, Zaida. 2 right. 2. The parallelogram. Did I drop your last month's salary? I did, right? I forget. No, right, Sadinsa? I dropped the last.
Yeah,
I did. Okay, exactly. This month also I'll drop it. Okay. I just remembered. I was like, did I pay you? I forgot. All right. So I have apparently. Okay. So coming back to the point. Remember, a parallelogram is made of 2 congruent triangles. But today we are not going to worry about the triangle, okay? In the infinity maths group, Sadinsa, infinity begins from? Exactly, Amna. Well done. Amna is doing a good job today. And you're right, Sadinsa. Exactly. Infinity begins from here. Infinity begins from here. In the infinity maths group, I told you that we are not going to do all of the geometry. So we have calculation geometry, right? We have constructions. We have proof geometry. And under the proof geometry, there are 2 shapes, right, Zaida? We have the circle and the triangle, right? We have those 2 shapes. But we can't do both of these shapes today. Today, we are going to focus only on the circle. Proof geometry circle, okay? So I'm going to erase all of these unnecessary parts. What are we learning today? We're learning about proof geometry and what category of proof geometry are we going to prioritize? What category of similar and equiangular? Actually, Ashfa, equiangular is not the right word. But yes, similar in our syllabus, similar and equiangular are the same, yes. But actually, in actual maths, equiangular has a different meaning. That's why I don't use that word. But in our syllabus, similar and equiangular are the same. In our syllabus, okay? Actually, there is a different meaning for equiangular. So, coming back to the point, we are going to only focus on the circle, right? Proof geometry circle. So we've got the tangents and the chords. Now actually, we're going to talk about the circle only. Circle, okay? There's another shape that you must become familiar with. Now, why are we talking about the circle? Javed sir loves circles. But look at my circle drawing skill, right, Sadinsa? Like, it's almost a perfect circle, right? I love perfect circles, Sadinsa. I'm a huge admirer of the circle. So, the circle, if someone asks, they will ask you this in the maths MCQ. In the maths MCQ, they will ask you, O-level maths MCQ, what is Javed sir's favorite shape? And you can tell them the circle is Javed sir's favorite shape, right, Sadinsa? So, as I was coming back to the as I was saying, all right, there's another shape that you must learn. If you take 4 chords, how many chords, Sadinsa? My God, no, chord. If you take 4 chords and you construct a shape inside the circle, if you take 4 chords and you construct a shape inside a circle, you construct a whole shape, a shape without a gap. That is called a cyclic. Can you guys tell me? It's called a cyclic. You're right, Zayda. A cyclic quadrilateral. So what is a cyclic quadrilateral? I've simplified it for you, okay? So when you think about geometry, right, Lena? When you think about geometry, you think about trigonometry, you think about the Pythagorean theorem, you think about volume, area, you think about magnitude, length, you think about constructions, you think about the triangle, the parallelogram. No. Today, we are only focusing on Javed sir's favorite shape, Sadin sir. No, the circle. The circle. And we're doing proof geometry. I am reminding you guys again. Proof geometry we are doing. That means we're going to learn the laws. The laws of circle theory, right? Laws or theory. The laws of circle theory. So we talked about tangents, we talked about chords. Now we have talked about the cyclic quadrilateral, and then there are pieces of the circle, all right? Now, for example, we have the center. These are not very important. These are not very important. We have the center. We have the circumference. I think everybody know what these are. We have the sector. We have the segment. We have arc. If you don't know these words, don't worry, okay? These are very simple words. We have arc. What else do we have, Sadin sir? We have semicircle, right? Semicircle. We have... that's it, right? Center, circumference, sector, segment, arc, and semicircle. Exactly. We only have these few words. So what you see on your screen, if you can screenshot, take a screenshot, right? If you can take a screen, not of Sadin's, of this, okay? Of the... I'll take my screen. I'm talking about this screenshot, okay? Take the screenshot of the note. This tells you everything you need to learn about a circle, okay? Everything you need to learn about circle theory, proof geometry, right? What are we talking about? We're talking about circle theory, proof geometry. All right. So, Satpat Gala, take a screenshot. Now we can get our hands dirty. If you are a student from the Infinity Maths group, Sadinsa, Infinity begins from?
Here.
Exactly, here, exactly. Infinity begins from here. If you are a student from the Infinity Maths group, you must have received a few flash cards, right, Sadinsa? Do you know what flash cards are? Absolutely, right. You can use them to study. All right, you can use them to study. And also remember, okay, Sadinsa is the host. He can remove you, okay? If you send a message, she will remove you from the class, okay? All right. Absolutely, Zaida. And yes, some of our students received the printed flashcards for free, right? So we'll send you printed tutorials also in the future. All right. So don't make Sadinsa angry, okay? Right? Her dad is Sarath Fonseca. All right. Sadinsa is the daughter of Sarath Fonseca. You know who that is, right? The army commander. And if you make her angry, she will remove you from the group, okay? She's a co-host. You are, right? She's going to remove you from the group. So coming back to the point, these are the flashcards. There are nine flashcards, okay? 9 flashcards. These are the flashcards that you have to learn. All right? And don't worry, they might seem difficult, but they are not. So what do you see on the screen, Sadinsa? There is a circle. There are chords. And there is a tangent, right? In all of these flashcards, you see a circle, you see chords, and you see a tangent. Here we see a chord, right? Here there is a chord. The chord is bisected by the center. So in this example, this is called the alternate segment theorem. Don't worry about memorizing these, okay? We will use these flashcards like playing Uno. Do you play Uno, Sadinsa? What do you like the most? Omi or Uno? What kind of a person are you? Omi or Uno? Or you hate both?
Hate both.
You hate, what is your favorite game, Sadinsa? Playing with hearts of, no, what is your favorite game, Sadinsa? No games. No, Snake and Ladder, Ludo.
Snake and ladders.
Snake and Ladder. Oh, okay. That's the, you play with snakes. Okay. That's good. Good to know, Sadinsa. All right. Very good. All right. I'm very proud of you, Sadinsa. So, my favorite board game is chess. I like playing chess. But then, when talking about these flashcards, we'll use them like playing Uno. So don't try to learn all of these flashcards now. It's no use. Let's use them like playing Uno. If you know how to play Uno, do you know how to play Uno, Sadinsa? You don't, right? That's why you hate it. That's why you get done at the hinda you hate it. I'll teach you one day. Come to my house. I will teach you to play Uno. Snake and ladders also we can play. Don't worry. Snake and ladders also we'll play. You bring a ladder, okay? You bring the ladder, but okay. So coming back to the point, you see that all of these flashcards have either tangents or chords. So here there are 3 chords, 1 tangent. Here, there are how many chords? Here I see there are 4 chords, right? Actually, 5 chords. 5 chords. There's 1 chord here. The chord is bisected by the center. Don't worry about learning these today, okay? Here there are 2 chords, right? 2 chords. Why is, Sadin tell me, why isn't AC and CD? Why aren't AC and CD chords? A chord must touch the circle in 2 places, right? Must touch 2 places of the circumference. A chord must touch 2 places of the circumference. So AC and CD are not chords, okay? I talked about this in the opening of our session. A chord must touch the circle in 2 places. The center is not on the circumference of the circle, okay? So there are 2 chords here. We'll talk about these techniques. We'll talk about these theories, okay? We have the angles in a semicircle. We have cyclic quadrilaterals. We have some laws regarding cyclic quadrilaterals. Don't worry. We'll teach you all of this, okay? We have the angles in a semicircle, right? We have that. The angles of a semicircle is 90 degrees, right? We'll talk about all of these, okay? Then we have tangents. There are 2 laws that you must learn under tangents. We'll talk about this, okay? We will talk about these laws, okay? We will talk about these laws very soon. But now, alternate. Oh my God, I got a message, but then I don't know. I lost the message. Zainab said it again, okay? So these are the theories that you have to learn, okay? So we have the alternate segment theorem. We have the angles in the same segment. We've got the perpendicular bisection of a chord. The chord is perpendicularly bisected by the center. We have the angle at the center theorem. We have the angles of a semicircle theorem. We have 2 laws regarding cyclic quadrilaterals. Remember, a cyclic quadrilateral is a 4-sided shape that is constructed by chords. 4 chords you use to construct a shape that is called a cyclic quadrilateral. Don't worry, we will be talking more about this. We have 2 laws regarding tangents. Finally, we have 2 laws regarding tangents. So we'll talk about all of these laws. So how many? Oh, alternate segment theorem. That's very simple, Zainab. So this is the alternate segment theorem, okay? Just think about this. Think about this. Without looking at the whole circle, look at the chords and the tangents, okay? Without looking at the whole circle, look at the chords and the tangents, okay? So Zainab wants me to explain what is the alternate segment theorem. I will be happy to explain. So we have not yet begun our questions. We're going to start doing the questions now, okay? We have the alternate segment theorem. Don't worry about the flashcards now. When we do questions, you can implement those 9 flashcards. The alternate segment theorem is one out of the 9 flashcards. So if you take this circle, all right, if you take this circle, this shape that is touching the circle from the outside, Zainab, what is this shape called? It's called this shape that is touching, absolutely, tangent. Well done, tangent. Now I am going to make an angle by using the tangent and a chord. All right? Using this chord, oh my God, right? Using this chord and tangent, I have made an angle, right, Zainab? Using, absolutely, Amna. Using the tangent and chord, I have made an angle, right? I have constructed an angle, haven't I? So I'll call this angle the theta angle, okay? Not angel, right, Sadinsa? Angle. I'll call this angle the theta angle, okay? All right, I'll call this angle the theta angle. This theta angle is between the tangent and the chord, right? Now, if you project, this is called subtend, right? Subtend. Now, if you subtend this chord and you make an angle, this angle is also theta. Can you understand, Zainab? Now, there are 2 segments, right, Zainab? Segment 1, this is a segment. This circle is broken into 2 segments. All right, if you take this circle, Zainab, this is broken into 2 segments. Segment 1 and then segment 2. This circle is broken into 2 segments. Now, the angle inside the first segment is equal to the angle on the other segment, right, Zainab? The angle inside the minus segment, the angle that is made between the chord and the tangent, is equal to the angle subtended inside the major segment. This is called the alternate segment theorem. Alternate means the other side, right? The other, alternate, the other. So the other segment theorem, alternate means the other segment theorem. Don't worry. Absolutely, I can show you hundreds of examples. Zainab, take a circle and we'll do examples from past paper questions. Zainab, take a circle. Zainab, can you take a circle? What is Javed sir's favorite shape? The circle, right? Right, Sadin sir? Let's make a tangent, right? Tangent. And let's also make a chord. There is an angle between the chord and the tangent. If you subtend this onto the opposite segment, the alternate segment, you get the same angle. One more time, Zainab, let's draw a circle, right? Let's draw a tangent, give the circle a tangent. Zainab, the tangent touches the circle from the outside, right? One place. Let's make a angle between the tangent and the circle. Let's make an angle between the tangent and the chord. If you subtend this chord the angle that is produced in the alternate segment is equal to the angle in the minor segment. Let's do it again. Let's do it again. If you draw a circle, and this circle has, if you draw a circle, and this circle has a tangent, this circle has a tangent, and if you make an angle between the tangent and the chord, if you subtend this chord, this angle is also equal to theta. It's called the alternate segment theorem. You can remember it like this. You can draw the circle, This, I think, is the most complicated theory out of the 9, right, Zainab? Draw the circle, right, Zainab? Draw the circle. Chord, tangent, angle, subtend, same angle. If you can't understand, don't worry. We will encounter these types of questions in our past papers. So let's take the past paper document, okay? There's algebraic geometry as well. Yes, there is. There's algebra as well in geometry, area and algebra. There's another part called area and algebra. Let me save that for later, okay? Area and algebra. Can you believe that? Our syllabus will not test lessons separately. They will mix the lessons, okay? They will mix the lessons. But this is geometry that we're talking about, proof geometry. So we have geometry separately, and this is circle theory. Brilliant. We have. All right. We have the 2016 past paper question, okay? We have the 2016 past paper question. It might seem difficult. Ane, it's not. Might seem difficult. We can do this now, okay? When are we going to do this? We're going to do it now. So please print out these documents before you join the class. It will cost you like 100 rupees, I think. Maximum 200 to get photocopies of this document. If you can't find a place, you can write the question down, right, Sadin sir? Isn't it raining there? It's not. Is it raining where you're from, Sadin sir? Oh my God. What?
Yeah, it's raining again.
It's raining again. It must be because of you, Sadin sir. The sky is in love. The sky is trying to get to you, Sadin sir. But then it's not raining here. Here it's at the hour. God hates me, Sadin sir, right? The sky hates me. The sky is like palayang, right? But then for you, the sky is very kind, Sadin sir. That's the problem. For you, the sky is very kind and it's raining and it might start to snow. Who knows? In a few days, it might start snowing. But here, it's patta rasne, okay? But we will. We are going to take a look at the 2016 past paper question. So like playing Uno, we have to find the flashcard, okay? Like playing Uno, we're going to find the flashcard. The center of a circle, I'm going to use both sides of my screen real estate. Going to use both sides of my screen real estate. All right. So like Sadinsa says, today we are going to focus on the circle, right? The circle is our shape today. Next week, we can do the triangle. So it's also raining. So right now, we have this question, and like playing Uno, we're going to find the correct flashcard, okay? So we have the flashcards here, right? We have the flashcards here. Circle theory flashcards. Like playing Uno, we're going to pull out the flashcard. So come play this game with me, Sadin. So everybody. So The center of a circle in the figure is O. Sadinsa. The center of the circle in the figure is O. And AB, BC, and AC are chords. I told you, right? Chords, they touch the circle from the outside or inside, Sadinsa. You can keep your mic unmuted, Sadinsa. You can keep talking with us. Absolutely, Amna, right? The chord touches the circle from the inside two places. There are three chords, right? Tell me, Lamai, is PD a chord? No. PD is not touching the circle properly. The chord must touch the circle properly in two places. PD is not touching the circle. It's shy like me, Sadinsa. It is very shy like me. So it's not touching the circle properly. There are only three chords. Oh my God. Oh my God. There are three chords. The center of a circle in the figure is O. And AB, BC, and AC are chords of the circle. P is the midpoint of AB. And the line drawn from P through O meets BC. So remember, O is the center. Don't forget, O is the center. O is the center. The line drawn from P through O meets BC at D. It is given that AOP is equal to X. Find ACD in terms of X and show that AODC is a cyclic quadrilateral. We can't do all of this at once. We must go step by step, right? We must go step by step, right? So here we are going to take a look at the first step, and that is, they say that BA is bisected, right? The first thing that I can see, all right, the first thing that I can see is that BA is bisected. This is the first thing that I can notice. The first law that we can notice is the bisection of a chord. Bisection of a chord. How is the chord bisected, by the way? How is the chord bisected, by the way? The chord will always be perpendicularly bisected. Can you guys understand? This is perpendicular, by the way. All right? This they have not given, but this bisection is perpendicular. Perpendicular bisection of the chord. Zainab, what has bisected the chord? What? BO is the radii. Can't we start by taking BO and AO as radii? AO is a radii. Well done. You're right. AO is a radii. Not. We'll get there. We'll get there. Okay. AO is a radii. Well done. So first of all, we can say that BPD, all right, or we can say that PD perpendicularly, all right, we can say that PD perpendicularly means equal to 90 degrees, okay? Perpendicularly means equal to 90 degrees. Perpendicularly bisects. Perpendicularly, Sadinsa, what does it do? Perpendicularly bisects BA. Are you wearing headphones, Sadinsa, today? You must be, right? All right. I hope you are. Okay. So perpendicularly bisects BA. Very simple. Okay. So where is the flashcard? I will flash the flashcard on the left. I will flash the flashcard on the left. Methienne, right? Perpendicular bisection of a chord. Zainab, what bisects the chord? What is doing this bisects? What is bisecting? What is doing this bisects? The center, right? The center. The center is bisecting. All right. The center, right, Sadinsa? The center is bisecting the chord AB. I use the word properly, right, Sadinsa? Bisecting. All right. So the center is bisecting the chord. Okay. So please catch up to where we are. This is the flashcard. Okay. This is the flashcard. The center will bisect the chord. If your teacher doesn't understand, tell her, madam, the center is bisecting the chord. True, right? If you draw a line from the center to the chord, right, it is a perpendicular bisection. If you draw a line from the center to the chord, it will become a perpendicular bisection. If it's bisected, it's perpendicular. If it is perpendicular, it is bisected. If it is bisected, it is perpendicular. If it is perpendicular, it is bisected. You can understand, right? All right. Now they say that AOP, this is the first step, okay? This is the first step. PD perpendicularly bisects BA. We use the bisection of a chord, okay? We have used the bisection of the chord. On the left side, we have our flashcard. If you can't understand, please raise your hands up. Your Javed sir is here to help you. I'm not here to bisect you. I'm here to help you. So what has bisected AB? It is the center, right? The center has absolutely, Wazim, I can help you. You want me to help you teach this, not bisects you, right? You want me to teach you this, right, Wazim? I'm making it clear. So what happened is, Wazim, do you see that AB is the chord, right? On the left side of the screen, AB is the chord. This AB is perpendicularly bisected by the center. The center bisects, all right? The center bisects AB. So now on our diagram, Wazim, do you see that BA has been bisected? On our diagram, Wazim, do you see that? Listen carefully or I will bisect you. Listen carefully, Wazim. BA has been bisected, right? BA has been bisected. So is this a normal bisection, Wazim, or is this a perpendicular bisection? Tell me, Wazim. Is it a normal bisection or is this a perpendicular bisection? Perpendicular. Why is it perpendicular, Wazim? Has the center done this bisection? Look carefully. Is the center responsible for this bisection? Absolutely, Amna, you're right. Perpendicular bisection, Wazim. The center is responsible for this bisection. Therefore, this is a perpendicular bisection. Therefore, this is a perpendicular bisection. You're here, Rukeya. My God, I didn't know. I thought that you dropped out, Rukeya, from our class. Okay. All right, so gonna move forward. You guys want to hear a story about Rukeya? I'll tell that later. I'll tell that story later. So this is the first step. Now they want you to find ACD. They want you to find this angle here. What to do? How to find this angle? You guys can see this angle here. I'll even highlight it in yellow color. I will even highlight it in yellow color. How do we find this angle? Please catch up to where we are. We don't have time to give you to write. You have to write as quick as you can, okay? I'm gonna do a construction. Now, why am I so sure about this construction? Why am I so sure about this construction? Because I want to implement my flashcards. Now I can't implement any of the flashcards. Right, Zainab? I can't implement any of the flashcards. Alternate segment theorem can I implement? No. No tangents, right? So my choices are limited. Therefore, Zainab, I am going to construct. This is called a production, not construction. Construction, colon, B produced to O. Make a small construction, B produced to O. Make a small construction. Now I can implement a theorem. Can my brilliant students tell me what is the next Uno flashcard that I can use? Wazim, can you tell me? Ruqayya, can you tell me? Amna, Zainab, Zaida, Lina. What is the next? No, flashcard. Isosceles triangle is not a flashcard, Zainab. I want the flashcard theory. What is the next flashcard theory that we can implement? What is the next flashcard theory that we can implement? We can implement the angle at the... Absolutely, I'm not genius, you are. Angle at the center, well done. Angle at the center theorem. We can use absolutely, Latif, you're right. We can use the angle at the center, not angel, Sadinsa, angle at the center theorem. We can use the angle at the center theorem. Before that, I don't know what this, I don't know what this angle is, right? I don't know what this angle is, right? This angle, I don't know, right? I don't know the angle at the center. But I know that if you take BPO, if you take the BPO triangle, right? And if you take another, what's the other triangle that is congruent to BPO? Please tell me. What is the other triangle that is congruent to BPO? Absolutely, POA, right? POA. If you take the BPO triangle and POA triangle, BP is equal to PA, it's given. Right? BP is equal to BA, it's given. BO is equal to OA. Why is BO equal to OA? Why is BO equal to OA? Well done, Lina. Well done, Latif, right? Well done, Amna. And you're right, Zainab, you're also right. Well done. And Zaida, exactly. Radii. These are radiuses, radii, right? These are radiuses, radii. BO is equal to OA. And finally, PO is common. Finally, PO is common. What does that mean? Therefore, BPO triangle is congruent to POA triangle. Therefore, BPO triangle is congruent to POA triangle. What does that mean? And well done, Ifra. The situation or the case is side, side, side. You can take right angle side as well, right angle, hypotenuse side as well. But we took side, 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 okay? We took side, side, side. Love it. And because of that, BOP, this angle is equal to X. Corresponding elements, right? Corresponding elements. Please catch up to where we are. When you are learning geometry, you must learn it step by step. You must go through this slow process. When learning geometry, you must go through this slow process. I know it's painful, but there is no other option. You must slow burn this process. You must slow burn this process. All right. Let's move forward. So now we know that this angle is equal to X, right? Not angel, angle, right? This angle is equal to X. Now, please catch up to where we are quickly, okay? Very quickly. So we showed that these two triangles are congruent. I'll even color these triangles, okay? I'll color them in a light blue color. We proved that these light blue color triangles are congruent to each other, which means their corresponding elements are also equal. Corresponding elements are also congruent. And what does that mean? The angle at the center is 2x, right? Don't you guys agree? The angle at the center, not angel, angle. The angle at the center is 2x. Angle at the center equals 2x. So for this, we are going to use the theorem, angle at the center theorem. For this, we are going to use the theorem, which is angle at the center theorem. All right? What is the angle at the center theorem? Here is the angle at the center theorem. Let me show you very quickly. Here is the angle at the center. There we go. Angle at the center theorem. Tell me this, Zainab. If the center is equal to 2x, what is the angle at the circumference equal to? Tell me this, my brilliant genius students. If the angle at the, well done, Zainab. If the angle at the center is equal to 2x, the angle at the circumference is equal to x. This is called the angle at the center theorem. Angle at the center is 2x degrees. So what is ACD's? What is ACD equal to? Because of that, ACD angle is equal to this green color dot angle, this yellow color angle, right? And well done, Hima. I'm very proud of you, and well done, Lena. ACD is equal to X. We have found ACD. ACD is equal to X. ACD is equal to X. We have found ACD. We have found ACD. Now, read the question. Now, catch up to where we are, please. Read the remaining of the question and tell me, how do we prove AODC is a cyclic quadrilateral? How do we catch up to where we are? Very quickly, okay? We can do two more questions. How do we prove that supplementary angles? Almost there, okay? Almost there, Zaida, almost. Angles is correct. Now, if you take, we can directly agree. We can directly agree. AODC is a cyclic quadrilateral. We can directly agree that AODC is a cyclic quadrilateral. Absolutely well done, Hima. Here is the Uno card, okay? Here is my Uno card. What is it? What is it? Why is AODC a cyclic quadrilateral? Interior angle is equal to the this means, what this means is, Zainab, there is another circle. What this means is, Zainab asks me a question. Where is the circle, right? Zainab is asking, so where's the circle? Zainab, there's another hidden circle like this. There's another hidden circle like this. Can you understand, Zainab? There is another small hidden circle. But they haven't drawn that circle because it will make the diagram more difficult, more kachal. There is another hidden circle. Remember ACDO, AODC, right, Zayda? AODC is a cyclic quadrilateral, but where is its circle? It's hidden. They have hidden the circle. Does this big circle belong to AODC? No. AODC has a smaller circle as such. AODC has a smaller circle, but we can't see it. But if we can't see the circle, Zainab, how are we sure that it is a cyclic quadrilateral? Interior. Interior means outside or inside? Inside. Interior angle equal to the opposite what angle? Interior angle is equal, well done, Zayda, opposite exterior angle. Interior angle is equal to the opposite exterior angle. If the interior angle, I can explain this very simply, Ifra. Now remember, we use the angle at the center theorem. I'll highlight the angle at the center, okay? Yellow color. What is this angle at the center equal to, Ifra? Ifa, apologies, Ifa. What is this angle at the center equal to how many x's? 2x's, right? Angle at the center, well done, Zayda. Angle at the center is equal to 2x's. If the angle at the center, Ifa, is equal to 2x, the angle at the circumference is equal to 1x. Here's the flashcard. If you still can't understand, let me know, please, okay? If you still can't understand, don't worry. I will not get angry. Ask Sadinsa. Sadinsa, have you ever seen me angry? Sadinsa gets more angrier than me. I have seen Sadinsa angry. She has not seen me angry, though. So this is the proof, by the way, Ifa. Can you see, Nangi? Angle at the center is equal to 2x. Angle at the circumference is equal to 1x. Angle at the center is equal to 2x. Angle at the circumference is equal to 1x. That's very simple. That part is very simple. But now, why is AODC a cyclic quadrilateral? Because the interior angle, what is the interior angle, by the way? X, right? X. Interior angle is X. Opposite exterior angle is also X. If the interior angle, I'll show the flashcard also. I'll flash the flashcard. I'm going to flash the flashcard, okay, Sadinsa? Have you you know how to flash the flashcard, right? So, you know what flashcard, right? Here it is, here it is. Interior angle is equal to the opposite exterior angle if the interior angle if the interior angle is equal to the opposite exterior angle, the shape is a cyclic quadrilateral. I can show the exterior angle, by the way. I can show the exterior angle, Zainab. Good question, okay? So don't be afraid to ask these questions. I'll show you the exterior angle. Here is the blue color exterior angle. Yellow color is the interior angle, Zainab. Blue color is the exterior angle. Can you understand? It's good, right? You have to ask questions like this. Absolutely. You have to ask questions like this. Only then will you actually learn. And really appreciate it. Some of you guys have classes also, right? Some of you have classes at 4 o'clock. Totally understood. So really appreciate that many of you joined today. And don't worry, we're going to save this lesson on YouTube. So this lesson will be available on our YouTube channel and you can access this lesson. You can tell your friends. You can help us, support us by commenting, by sharing, right? Subscribing, right? Like, share, and subscribe, they say. So what is the YouTube channel called, Sadinsa? What is our YouTube channel called? Infinity Maths, right? Infinity begins from here, right? Let's go to the next question. We can do 2 more questions. Let's do the 2000. Any more doubts that you guys have? Any more doubts? Absolutely. Infinity Maths Zayda. That is what the YouTube channel is called. Let's do the 2017 past paper question. If you're done with the previous question, you can come to the 2017 past paper question. The time right now is 4:17. And like I planned, the 2017 past paper question is being discussed. What geometry is this? This is not ordinary geometry. This is proof geometry. This is proof geometry. Circle theory, right? Circle theory. Proof geometry, circle theory. All right. Brilliant. So now I think you can understand why we call this proof geometry. Are we doing calculations? Are we doing? No, not a single calculation. We proved. No calculations, no area, no magnitude, no lengths, no volume, trigonometry, no Pythagorean theorem, absolutely not. No calculations, purely proof geometry. We're doing the 2017 past paper question now. ABC are 3 points on a circle given in the figure. CB is a diameter. CB is the diameter. So that means the center is somewhere here, right? Center will be somewhere here. CB is a diameter of the given circle. The line CB produced means dikkaranava. What does that mean, Sadinsa? Produced means dikkaranava. So what is a producer? All right. Produced. And I'm also a producer. And the tangent drawn to the circle at A meets Q. Moreover, point E lies on other tangent lies on the other tangent drawn to the circle from Q, such that CAQE is a cyclic quadrilateral. Zainab, there is a bigger circle. How many circles are there? There are two circles. The second circle you can't see. There is another circle. Remember, according to the question, there is another circle like this. I'll use an actual circle. I'll use an actual circle, by the way, than guessing it. I'll use an actual circle, by the way, than just doing some guessing work. There is another circle, but where is that circle? That circle has been hidden. There is another circle, but this circle has been hidden, right? This circle has been hidden from us. There is a bigger circle here, but this circle has been hidden from us. There we go, right? So there it's, can you see when there are two circles, it's difficult to focus, right? Can you guys understand? There is a second circle, a big circle, but because of that, it's difficult to focus. So they have hidden the second circle. But remember, A, Q, E, C, or CAQE, I'll even highlight CAQE for you. CAQE, this is a cyclic quadrilateral. Love it. Very beautiful. Sadins. Are you paying attention? If ACB equals X, there we go, ACB equals X, then show that BCE, this part, this locucal here, right? I'll even put a dot. BCE is equal to 3x. Ammata Siri. We can do it. We can do it. Don't worry. All right. So it's a very simple question, but we have to go through a few steps. It's a very simple question, but we have to go through a few steps, okay? But don't worry. If you go step by step, right? If you go step by step, you can get the answer. I'll give you some time to draw the diagram, right? I'll give you guys some time to draw the diagram. I'll also give you some time to think about the theories that we can implement. I will also give you some time to think about the theories that we can implement. What do you guys think? Now, remember, there are not only chords, but there are also tangents. Not only are there chords, there are also tangents. So you have to think about many of the theories. Number one, I'll make it easy, okay? Number one, we have the angle, number one theory, all right? I'll put a Roman number one. We can use angle of a semicircle. Number one, we can use the angle of a semicircle, right? We can use the angle. What is the angle of a semicircle? How much is that equal to? I'll show you the flashcard. I will show you the flashcard. What is the angle of a semicircle equal to? The angle of a semicircle is equal to 90 degrees. Well done, Hima. Well done, Zainab. The angle of a semicircle is equal to 90 degrees. What is equal to 90 degrees? What is the angle of the semicircle in this situation? What is the angle of the semicircle in this situation? In this situation, the angle of the semicircle is equal to The angle of the semicircle is CAB, right? CAB is 90 degrees. In this situation, the absolutely well done, Zaida. The angle of the semicircle is equal to 90 degrees. In this situation, the angle of the semicircle is equal to 90 degrees. The angle of the semicircle is a CAB, obviously, in this situation. Step 1 done. I'll use a different color pen. So the note will pop. There we go. Love it, love it. So what is, now you guys can see an angle here, right? You guys can see an angle here. What is this angle equal to? What is this angle equal to? You guys can see an angle here. What is this angle equal to? Can someone tell me? I'll use a different color. I'll highlight it in yellow color. Might seem difficult. It's not difficult, okay? There are only 9 laws. What is this? What is this yellow color angle equal to? What is this yellow color angle equal to? This yellow angle here. Zainab. Absolutely well done. Zainab says X. You're right. Ifa. Absolutely. We can use the alternate segment theorem. Number 2. BAQ is equal to X. This is the alternate segment theorem. Alternate segment theorem. BAQ is equal to X. This is the alternate segment theorem. If you can't understand, please put your hands up. Don't worry, I won't get angry. All right? Don't worry, I won't get angry. If you can't understand, please put your hands up. I will even, and don't worry, sometimes you might feel shy, right? Ashamed. You might feel ashamed to raise your hands up. But no, you're not here to impress other people. The only person here to impress me is Sadinsa. You're not here to impress other people. You are here to learn. So if you don't know, tell me that you don't know. I will explain. So this is the alternate segment theorem, right? We're using the alternate segment theorem. Very simple, right? We're using the alternate segment theorem. This is equal to X. Can someone tell me what this angle is equal to? Can someone tell me? What? Paul, we don't need this angle. Can someone please tell me what this angle is equal to? Can someone please tell me what this angle is equal to? I'll color this angle in red color. What is this red angle equal? What is the value of this red angle with regards to X? What is the value of this red angle? You know the answer. You know the answer, definitely. Take the triangle CAQ. Take the triangle CAQ, right? CAQ, triangle. All right? X plus 90 plus X plus AQB is equal to what? If you take the triangle CAQ, X plus absolutely 180, right? You got it. You got it. Now you can find this red color angle. Now you can find this red color angle, right? Now you guys can find this red color angle. AQB, right? AQB. X plus 90 plus X plus AQB is equal to 180, right? Sum of the interior angles, right? Sum of interior angles. You have to write the law by the way, okay? You must write the law by the way. Sum of interior angles, right? That's easy, right? Sum of interior angles. Good, good. All quarter. If you can't understand, please tell me. But now you can ask me, Javed, sir. There are 4 angles here, right, sir? There are 4 angles here, right? How did we get 4 angles? A triangle only has 3 interior angles. How did we get 4 interior angles? Look very carefully. There is an angle with x plus 90, right? There is this angle. This belongs to a triangle. This angle is equal to x plus 90. This angle is equal to x plus 90. Therefore, AQB angle is equal to 90 minus 2x. Catch up to where we are, please, okay? Bloody catch up to where we are. Might seem difficult, but you must go step by step. It is like playing chess. It is like playing chess. Can't we consider triangle CAB? AQB is AQB is not the exterior angle. ABQ is the exterior angle, right? AQB is not the exterior angle. ABQ is the exterior angle. That will make things more difficult. Don't you agree, Zaida? AQB is not the exterior angle. ABQ is the exterior angle. Therefore, it will make things more complicated. We found AQB. Catch up to where we are, okay? We found AQB. We're gonna make another construction. No, we don't have to make another construction. We don't have to make another construction. AQB is equal to BQE. Why is AQB equal to BQE? Why is AQB equal to BQE? Someone tell me. It became a bit difficult. Why is AQB equal to BQE? It became a bit difficult. The tangents doing? The 2 tangents, well done. You're right, Zainab. 2 tangents are? 2 tangents are? 2 tangents are? Meetangents, I think I'm lagging, I don't know. 2 tangents are meeting, right? Can you understand? In this situation, absolutely. 2 tangents meet. You can just say 2 tangents meet. 2 tangents meet. Bisected by the center. You can write 2 tangents meet bisected by the center. This must be a bit difficult. But remember, this red color angle is 90 minus 2x. This red color angle is equal to 90 minus 2x. This other angle is also equal to 90 minus 2x. This red color angle is equal to 90 minus 2x. The other angle is also equal to 90 minus 2x. If you can't understand, please raise your hands up. The flashcard is on the left side. I'll draw the two tangents. I'll show you the two tangents. These are the two tangents, okay? The angle that is formed when two tangents meet is bisected. If you can't understand, please let me know. But remember, AQB is equal to BQE. AQB is equal to BQE. The reason is D. When two tangents meet, the angle is bisected by the center. Lastly, we can use the theorem absolutely opposite angles. Interior angles are supplementary. Well done, Zainab. In the end, you got the answer. Well done. You got it. Very proud of you. Geometry is very easy, but why do students think it's difficult? In this situation, sometimes you might have thought of trigonometry, Pythagorean theorem. Is there a use of talking about trigonometry, Pythagorean theorem? No. No use at all. Is there a use of talking about the midpoint theorem? No. No use at all. In this situation, we must focus on the circle theory. In this situation, we are focusing on the circle proof geometry only. If you can't understand, please put your hands up. It is very simple, okay? It is very simple. You can use the left side. You can use the left side. So remember, AQB is equal to BQE. Now, if you take, now look at the question carefully, they want you to say that BCE is equal to 3x. This green colored dot, they want you to find this green colored dot is equal to 3x. If you take the CAQE, what is the shape? Cyclic quadrilateral. If you take the CAQE, cyclic quadrilateral, if you take this cyclic quadrilateral, if you take x plus BCE plus 90 minus 2x into 2 plus 90 minus 2x plus 90 minus 2x. This is equal to what? What is this equal to? Can someone please tell me? What is this equal to? If you take x, if you take BCE, if you take 90 minus 2x, if you take another 90 minus 2x, well done, Zainab. Lena, you're right, 180. What is the flash card? Where's the Uno card? Zainab, where is the Uno card? Here is the Uno card. Here is the Uno card. Interior opposite angles. Sum of interior opposite angles. This is the first. This is the first interior angle. This is the second interior angle. The blue color one is the first interior angle. The green color one is the second interior angle. Sum of interior, sum of pair of interior opposite angles are supplementary. Interior opposite angles are supplementary. Interior opposite angles are supplementary. What is supplementary, by the way? Equal to 180. Interior opposite angles are supplementary. Well done, Zaida. If you can't understand, please let me know. What will you get? X plus BCE plus 180 minus what? Minus what is equal to 180? Minus what? Tell me the next step. Minus what is equal to 180? Tell me the next step. My brilliant students. X plus BCE plus 180 minus, get rid of the brackets. Get rid of the brackets, please. Tell me the answer if you can. It's not difficult as you guys think. It's not difficult. I'll show you again, okay? I'll show you guys again. X plus BCE plus 90 minus 2x plus 90 minus 2x equals 180. X BCE plus 90 or 180? Plus 90 or 180? 180, right? 180. So we have to simplify this expression. There is BCE. 90 and 90 is 180. Negative 2x, negative 2x. How much is negative 2x? And well done, Zaida. How much is negative 2x, negative 2x? Negative. How many x's? Negative 2x, negative 2x. Think about this. If I took 2 apples and I took 2 more apples, how many apples have I taken? Think carefully, Lena. If I took 2 apples and took 2 more apples, I have taken 4 apples, right? Taken is negative. If I took 2 apples and took 2 more apples, I have taken negative 4x. Positive x. Don't forget the positive x. Equals 180. Please catch up to where we are. We're almost done, okay? We're almost done. We're almost done. We're almost done, okay? BCE plus 180 minus how many x's? What is the final answer? Negative 4x, positive x. I took 4 apples, I gave you 1 back. So how many apples have I taken? Well done, Zaida. I took 4 apples, I gave you 1 apple back. Negative 4, positive x. How many apples have I taken? Took 4 apples, gave you 1 back. How many apples have I taken? I have taken 3 apples, right? Right, Sajida? I have. Absolutely, Sajida. The recording will be available, okay? Recording, I'll make it available under our YouTube channel. Negative, right, Lena? Negative 3x. Don't forget negative, okay? Negative 3x equals 180. BCE, let's take these elements, these expressions to the other side. Let's take these expressions to the other side. Right? BCE, apologies, 180. If I'm going to take this 180 to the other side, it will become negative 180, right? If I take this negative 3x to the other side, what will it turn into? If I take this negative 3x zeta to the other side, it will become, well done, positive 3x. If I take the negative 3x to the other side, it will become positive 3x. So BCE is equal to what? What is BCE equal to? BCE is equal to 180 minus 180. What is it? 180 minus 180 is 0. 0 plus 3x. So what is the answer? BCE is equal to 3x. We did it. It might seem difficult, okay? It might seem difficult. But the more you practice, it becomes easier, right? You left us, Sadinsa. I think she became Maruna Wage, right? Maybe she turned off the cam and she went for a small nap.
No, I'm there.
You're there, my God, Sadin. So glad you're here. We'll be done very soon, okay? Sadin, so what's the plan for the weekend? Gangwatura to sub. You wanna give a support for the Gangwatura victims, maybe, right?
Yeah, we supported.
You did. What did you do to them?
We
I'm
gave
also. You gave what?
dry ration bags, like we prepped up.
Dry ration bags. Okay, so I'm also a Gangwatura victim, Kenik. So what will you give me, Sadinsa? Wet ration bag. Do you have dry ration bags? Will you give me wet ration bags? I'm also a Gangwatura. Mat asaranai pau. So, this might seem difficult. I promise it's not. You have to practice more and more, okay? Let's do. We have a few more minutes. Let's do an easy question, okay? We have a few more minutes. Let's do an easy question, all right? Let's do a first paper question because the second paper question will take longer. But remember, all you have to do is you have to memorize the theory. There are 9 flashcards. You have to memorize those 9 flashcards. There are 9 flashcards. You must memorize those 9 flashcards. Brilliant. We'll do an easy question, okay? We will do an easy question from proof geometry. There's a first paper as well. So now we're going to look at the first paper, okay? Now we're going to look at the first paper. Yeah, a few seconds. Okay. Now let's do some questions from the first paper, okay? Because we don't have time to do another big question. Will I be able to explain this, Zainab asks. Okay, we'll see. It's not a geometry question, right? Because this is a geometry question. That's the problem, Zainab. Give me a second. Point X is located within a... This is a parallelogram. Oh, this is... when there's a parallelogram, Zainab, this is for the triangle. This theory is regarding triangle proof geometry. So sadly, we can't do this today because today we are focusing on the circle proof geometry. But can you drop this in our Infinity Maths group, Zainab? In that group, if you drop it in our next session, when we do a triangle proof geometry, I will prioritize this question. In the beginning of this session, I told you guys that a parallelogram, okay? A parallelogram is made of 2 congruent triangles, right? In the beginning of our session, I told you that a parallelogram is actually made of 2 congruent triangles. Regardless, right now, we're going to focus on some first paper questions, and we'll be done very soon, okay, Sadinsa? I won't keep you for long. As I was saying, We're going to take a look at the first paper now. So I'm going to save this for later, okay? We'll do more of these questions in our future sessions. Don't worry. Infinity Maths will be around for a very long time, right? We can't call ourselves Infinity Maths and we can't disappear tomorrow. Infinity, right, Sadinsa, has to last forever. So we're going to have more sessions, I promise. All right. So let's do this question here, okay? Let's do this question here. Question number 18. This is from the first paper. You don't have this, by the way. I did not drop this in our group because I wanted to do only the second paper questions. But because we are out of time, we're going to do questions from the first paper using the information given in the figure. Find the magnitude of CDA. They want you to find the magnitude of this. Can you guys drop in the chat? What is the magnitude of CDA? CDA is equal to how many degrees? Remember, ABCD is a... Absolutely, you're right. You're right, Zaida. You gave me the answer. Very proud of you. If you're right, 100 degrees. The reason is, right, CDA is a cyclic quadrilateral. Okay? CDA is a cyclic quadrilateral. All right? And the opposite? Opposite. Interior angles, right? Interior angles are supplementary. What do you mean by supplementary? Equal to 180. Sum is equal to 180, right? That is what supplementary means. Here is the flashcard. Here is the flashcard, by the way. All right? The sum of the opposite interior angles of a cyclic quadrilateral totals to 180, right? Brilliant. Very simple. Took only a few seconds, right, Zaida? If you couldn't understand this, please put your hands up. Everybody did. Don't even write this down, okay? Don't even write this down. It's silly. It's like a brain exercise for you, right? For Javed's students. Right, Sadinsa? This is a brain exercise. Speaking of exercise, Sadinsa, have you been to the gym recently? You look like you have exercised well.
Yeah.
You'd have? When was the last time you went? Yesterday. So you told me you were helping the Asarana victims of the flood. You were lying, right? What? You were giving them weights, right? Here, take this dumbbell, right? Malli. Minna dumbbell එක ගන්න malli, right? Take this dumbbell. Is that what you did? So, but you look well exercised, Sadinsa. You look like you've done some good exercises. Okay. So coming back to the point. Question number 19. So where was the place that you helped though? What was the place that you helped? Location එක?
You know Jaltara at Homagama?
Homagama. So they had a flood, really?
Yeah, Jaltara. It's a
That's
park.
why it's what?
It's around Homagama.
Oh, I see. Okay, so they had flood. Oh my God. All right. So that's I didn't know, but now I do. All right. So coming back to the point. So when I coming to our area, Sadinsa, so only Jalthara, not Kolonna. Api පැත්තට එහෙම එන්නේ නැහැ. එවෙන්නේ නැහැ. Racists. Okay, I'm kidding. The radius of the circle with the don't write this down. Mental exercises, okay? Because we're all mental. Mental exercises. The radius with the figure, with the center, oh my God, center O in the figure, right, Sadinsa, is 10 centimeters. All right? Find the length of the chord AB loop. So first of all, the radius, these are radii, right? Aren't they? I'll use a softer stroke. But you can easily identify that these are radii, right? AO is a radii and then OB is a radii. 10 centimeters. You can draw them on the diagram itself. 10 centimeters. They want you to find the length of the AB chord. So I can't find the AB chord yet. But I have to implement, it can't be, I have to implement the Pythagorean theorem, right? In this situation, I must implement the Pythagorean theorem. Implementing. This is the first paper, okay? So we have calculation geometry. We must implement the Pythagorean theorem. Do you know Pythagoras? You know the Pythagorean theorem, Sadin sir? He's one of my students, Pythagoras. I'm the person who gave him the name. One day he showed me one of his math sums. One day he showed me something. And from that day onwards, I call him Pythagoras. All right. Pythagoras. I thought you studied in English medium, Sadin. How do you know these words? I thought you studied in English medium. How do you know all of these words, Sadin? Pythagorean theorem. All right. 10 square. I'll call this x, okay? I'll call one of these sides x. By the way, these will be perpendicularly bisected. Remember that, okay? Perpendicularly what? We talked about this. You have to know the theory. Perpendicularly bisected. Is this in our flashcard? What do you think, Sadin sir? Do we have this in our flashcard? Yes, we do. Absolutely right. Right, this is Javed sir's class, right? Hell yes, there we go. Perpendicularly bisected. Again, I'll show you guys. Perpendicularly bisected. So obviously, what is it? AB is being perpendicularly bisected. All right. So now, so O is perpendicularly bisecting AB, right? So now I have to implement the Pythagorean theorem. So x square plus 8 square equals the square of 10. Here, this 10 centimeters is the hypotenuse, right? I think everybody knows this word. The hypotenuse is the side of a right angle triangle that is opposite of the right angle. So x square equals 100 minus 64, right? X square equals 36. X equals 6. 2x equals how many centimeters? Absolutely. Don't forget, you must write centimeters. If not, you won't get the whole marks. You might lose half a mark or you might lose 1 mark. So you must you must mention the units, right, Sadinsa? Units. Little bit distracted I am today. Easy. This was easy, right? If you have any doubts, please let me know, but you have to mention the perpendicularly bisected part, okay? If not, you won't get full marks. You have to mention the perpendicularly bisected part. It is a law when it comes to circle theory. Let's keep pushing forward. Question number 22. A few more questions and we are done, okay? Really appreciate that you guys were here. The center of the circle in the figure lies on AC, right, Sadinsa? AC. Find the magnitude of CBD. Lakna, we can do it. This is CBD, right? This is CBD. Okay. Now, first of all, tell me, can you guys see this green color angle? What is the magnitude of this green color angle? Can someone tell me? What is the magnitude of this green color angle? Obviously, it is. You're right, Zainab. You're right. 25, right? DBA is equal to 25. The reason is same segment, right? Angles of the same segment. That's easy, right? 25. This green color angle is equal to 25 degrees. If you can't understand, please let me know. The reason why I am rushing is because I believe that you guys find this to be very easy, right, Sadin sir? Absolutely. Well done, Zayda. Also, CBA. CBA is equal to 90 degrees. Why is CBA equal to 90 degrees? Angle, absolutely, Zayda, angle of a semicircle. Angle of a semicircle, right? So what's the plan after the class, Sadin? So what are you going to do now? In the chat, they ask.
Actually, I got some clothes to fold. That's
You
all.
got some clothes to fold? So you're gonna put away your clothes, right? You got some laundry to do, I guess. That's what you say, laundry to do. You're gonna organize your wardrobe. That's what you would. That's what proper what I would say. Organize your wardrobe, Sadin sir. Well, see, Javeds are teaching you so much, right? I don't know English. My English is bad because I teach maths, Sadin sir. But I think the correct English form is organize your wardrobe. In the chat, people are asking me whether you're my sister. We look alike. We have the same nose, I think, right, Sadin sir? Did your dad or mom, are they friends with my parents? Something, I don't know. Ask your mom or dad, they know my parents. We have the same nose, yeah. Very good. Students, very good. Now, that's how math students should be, they have to be very observing, right? They have to observe well, right, Zaida? So good observations, well done. So Sadinsa is not my legal sister, but then I don't know what happened. Okay, have to ask her parents and my parents. So we, you're not wearing headphones. Who is there? Someone listening to what I'm saying, Sadinsa? No, right? Oh shit. Okay. So I don't know, man. We have the same nose. Ask your mom why do we have the same. I don't know, man. The kids pointed it out. So coming back to the point. So CBD is equal to 90 minus what? Absolutely, say the 90 minus 25, right? 90 minus 25. Remember, this is perpendicular. So CBD is equal to 90 minus 25, which is your right, 65. Geniuses you guys are. Last question, and then we are done. If you couldn't understand, please put your hands up. A few more seconds. Sadinsa has to go organize a wardrobe. No, she has to go fold clothes. I'm kidding. Organize a wardrobe, she has to. We can't keep Sadinsa waiting, okay? Your dad is Sarath Fonseca. He's going to shoot you guys, okay? He will shoot you guys. So we can't keep her waiting, okay? AB is last question, okay? Question number 13 of the 2017 past paper, first paper. AB is the diameter of the circle with the center O. The point C lies on the circle if AB is equal to 10 centimeters. CB is equal to 6 centimeters. Find AC. You guys know that ACB is equal to 90 degrees. What is the proof? Tell me, last question. What is the proof, by the way? What is the proof? It is angle. Absolutely geniuses, you guys are. You're right, Zayda. And you are right, Zainab, right? Angles, you rejoined 3 times. Can't hear me. You can, no, there's something wrong with your device, Zainab. Everyone else can hear me, sadly. Angles of a semicircle. There we go. Angles of a semicircle theorem, right? So now we can implement the what theorem? Sadin sir, you know my student. What's his name? Pythagorean, right? Pythagorean theorem. So one day, one of my students showed me something. And from that day onwards, I started calling him Pythagoras. So my student, Pythagoras, invented this. Actually, I taught him this. I taught Pythagoras this theorem, and he made it famous. So what is this Javed theorem? It was called Javed theorem, but now it's called Pythagorean theorem. What is this Javed theorem? It is basically the sum of the squared sides. The sum of the squared sides is equal to the square of the hypotenuse. Everybody knows the Pythagorean theorem, right? 64 plus x square equals 100, x square equals 36. X equals how many centimeters? X equals 6 centimeters, right? The square root of 36 is 6. We're done. Speaking of 6, the time is 5:06. 5:06, right, Sadinsa? So we're done right on schedule. So proud that you guys were here. I'll see you guys in our next session. If you like, you can complete all of these questions and you can upload them into our Infinity Maths group. Sadinsa, infinity begins from.
Yeah.
Infinity begins from here. I will see you guys in our next session. And until then, take care and all the best.